Okay, guys, so we're going to move into application. So this problem right here, you're riding your bike and a dandelion spore hits the middle part of your front wheel. And of course you're riding your bike, so the dandelion spore gets attached to the wheel, so it goes down and eventually it's on the ground, but then it goes up again, and at this point it's the same height as it was in the original when it first attached to your tire. And then it goes up, it maxes out right there, and then it arrives at where it first attached to your tire, and then it just keeps on going around and around and around. So that's the dandelion spore's life right now. It gets attached to the wheel and then just spins around as the wheel spins around and around. So this is a circle, and we can talk about the height of that dandelion spore as a function. And that's exactly what we're going to do. We're going to find the height of that dandelion spore based on time. So that's two variables I mentioned, height and time. So we're talking about a function with domain and range. The domain is time, and it's going to produce a height, which is the range. So how do we do this? Well, let's first figure out, well, I always like to start with the max and the min height of my dandelion spore. The dandelion spore eventually is going to be on the ground. I mean, it's going to be on the tire, but adjacent to the ground. So the lowest height that dandelion spore will be 0. And eventually the dandelion spore is going to be at the top of the tire right there. How far above is that? Well, the diameter of the circle, the diameter of the tire is 24 inches. So 24. Now, since I know my max and my min range values, I can figure out my midline. Whatever y value is right in the middle, and that is 12. So my midline is 12. So when I write my function, it's going to end in plus 12. And then since I know my midline, I must know my amplitude. How far from the midline to the top, how far from the midline to the bottom, that's also 12. So my amplitude is 12, but right now I'm not sure if it's going to be positive 12 or negative 12. So let's continue drawing. When the dandelion spore hits my tire, it hits it at the middle, I was told. And then looking at the tire, it goes down first, then up, then down again, etc., etc., etc. Well, I started at the midline, and we know that that means we're using sine. And since when I started, I went down, that is in the opposite direction that the parent function usually goes. So now I know it's a negative a value. So I've got almost everything. The thing there's no phase shift. We're gonna just assume that the time begins at 0. So I don't have to worry about phase shifting left or right. But I do need to figure out the b value. So the 16 mile an hour is something I don't need to use right now. This, 4 revolutions per second, that. 4 revolutions, so I spin around 4 times per second. And the period is how long do I need to do one whole cycle? In other words, how many seconds need to pass by before I do one complete revolution? I could do 4 revolutions in a second. How long do I need to do just one revolution? Well, mathematically, you could divide by 4, but I'm sure you could just figure out your own shortcut and discover that 1 revolution will occur in a quarter of a second. So the period is 1/4, 1/4. Well, the b value for sine and cosine is always 2 pi divided by the period. So 2 pi divided by 1/4 gets you 8 pi. So there's the b value, 8 pi. I'm doing 8 pi revolutions in a 2 pi distance. You can think of it that way, but b is 8 pi. It's also your speed. So there's the function. The height, oops, I gotta do t, not x. The height of the dandelion spore based on time in seconds. The height in inches based on time in seconds can be expressed by this function. And when we see each other again, we will answer these questions. You know, what's the height at 7/48 of a second? You just plug in 7/48 into t, and figure it out. Once you have the function, you have a very powerful position. You can find the height at any time. And if you know the height, you can find the time just by working backwards. Let's have you try this one. Now, if you're a movie fan, The Third Man is one of the best movies ever created. So if you really love movies, find The Third Man and watch it. Anyway, there's a famous scene where two people go into a Ferris wheel. One of them is Harry Lime. So we're going to talk about the height of Harry Lime. And I want you to create this on your own. So first, read the paragraph. And then I want you to find what is the maximum height and the minimum height once Harry's on the Ferris wheel. Well, the maximum height is 72. Because let's start with the minimum height first. The minimum height is 12 feet. Because when he says when you enter the carriage, you're already 12 feet up in the air. And the diameter of this big Ferris wheel is 60 feet. So if you're down here, you're 12 feet up in the air. Well, 60 feet later, you're 72 feet in the air. So you know your max height and your min height. And when you know your max and your min, let's just draw a little situation here. So Harry Lime boards the Ferris wheel, of course, at the bottom. So right there, we know what function we're using. But anyway, let's do this in order. I know my max height and I know my mid height. If you know the max and you know the min, then you must know the midline. What is the midline? The midline is the number right in the middle, which is 42. If you know the midline, then you know the amplitude. You know the midline, you know the middle, which is 42. Well, how far from 42 do you need to go up to reach the max or to go down to reach the minimum? You'd have to travel 30. So the amplitude is 30. All right, now is this cosine or is this sine? We're starting at the bottom. So is this cosine or is this sine? It is cosine, very, very good. Now the period, how long does it take for one full revolution to occur? Let's see here. The whole ride is 66 minutes. So the period is simply 66. The ride is one revolution around. So the B value is what? The B value is always 2 pi divided by the period. So it's 2 pi divided by pi over 33. And then what is the final equation here? We have to put all this data into this equation. We know it's cosine. We start at the bottom, so the A value is going to be negative, and you've got the rest.